Good morning. Good morning, everyone. Let me just start this discussion, right? So the question we are asking here today is what should India's science ambition be, right? And, there are two facets to this question, which I'll talk about. And I see we have a lot of school students here. So what I'll request my co-panelists is that as we discuss this topic, if we can use more examples and, give them examples of, let's say, what applied research is, basic research is, and so on. That might get them more involved in this discussion, right? So the first facet of the question we are asking is that what kind of science India should do. And when I'm using the word science, basically I'm talking about both science and technology, but creation of new knowledge in science and technology and then translation of that new knowledge, that is making industry and startups use that knowledge to bring out new products, right? Like there's this example of the iPhone, which combines a lot of technologies in AI, speech recognition, GPS, and so on to come out. So some of the questions which plague when India thinks about this is, and there are 2-3 issues, right, as to what India should be doing in science. So some people think that we should be doing more basic research, right, which is also called, I like to call it open-ended research, right? More blue sky research, which kind of creates disruptions like deep learning in AI, versus some people think that a country like India should do more translational research, which is now and here where we can make products which people can use, right? So that is one of the questions which comes again and again in front of India. And remember that the context is that India is still a developing nation, right? We have many competing priorities among S&T, right? Economic development, social development, and so on. So should we focus on basic or applied, right? Another question which comes in is that should we be doing more mission-oriented research, right? Like spending rockets to Mars and doing that kind of research. And someone might say, oh, that's a waste of money. Why is India sending rockets to the space, right? Or otherwise, there could be very, very useful, economically useful missions like around electric cars or water management and so on, right? A third issue which comes is around massification versus excellence, right? So we have all these students who are sitting here. Should we be inspiring them to become the next Nobel laureates? Of course, the answer of that is in any circumstances, yes. But as a country, should we develop systems for saying that how do we get excellence and do the best science in the world? Or we spread it, we should think about massification and getting more and more people included in science, right? And one more topic which I'll talk about, which people get very, very also sentimental about sometimes, is that they feel that scientists are doing work which is disconnected to Indian problems and issues. So there's a lot many voices within India who say that, guys, scientists should be working on Indian problems, right? Like we want to clean the Ganga, it's been dirty for so many years, and everyone here would want that Ganga gets clean. So should our scientists be focused and say, hey, think about cleaning the Ganga rather than thinking about how to make the next image tagging algorithm, for Google. So those are some of the issues which are there on what kind of science and technology India should be doing. The other issue is what should be the scale of our ambition. How big our ambition should be. Again, given that we have competing priorities. And a small story I can tell from the first India Science Festival, right, which happened just to talk about the scale of ambition. So we had one panel like this where the topic was, it was a provocative title, that how do you build an MIT in India? Right, that was the title of the panel. And we had one director of an Indian institute, science institute, and his remarks were that, no, we are doing great, right? Why do you are even asking this question? Indian institutions are doing great and we are out there. Now contrast with another panel which I was moderating, which was where we had a panelist from China, right? And from our audience, the context is that if you look at China today, it has many universities which are now competing with an MIT or a Stanford, like with the Tsinghua University being an example. And so I asked this Chinese panelist and I said that, you guys have been doing very well. You've made these investments in the last 30 years. They are excellent results. So we want to learn from you. What did you do? How did you do? And his response to me was, no, we are not doing well. Who says we are doing well, right? How many Nobel laureates do we create, right? How many world-changing inventions and discoveries do we do? So just the scale of the ambition is like skyrocketing, right? So, where should we peg our science ambition is the other question, right? So the two questions are what kind of science and tech we should do and how high should we go given the competing priorities we have? And one question, I want all of you to think about, which I'll ask quickly in 2 lines at the end of the panel, is that if we are in 2030, right, what should have India done that we'll say that India has become successful in its science and tech agenda? So with that background, maybe Thomas, you can add some international color on what you've been seeing across the world, and where do you see India fit in and what India should be doing?
Thank you very much, Varun, and hello to everyone. As far as I'm concerned, this century is India's for the taking. If you look at the Indian research and innovation system, it is today situated in a position very similar to that of China's 20 years ago. GDP is similar, the amount of money spent on research is similar, but India actually has some advantages that China lacked. A free and democratic society is actually a huge advantage if you want to be a country that makes discoveries. India also has an extraordinary tradition of successful advances in mathematical sciences. And we are currently living in an information age. There is no area of research in which you would want to have capability more than that one. Perhaps most important of all are the people I see in front of me today. India has the perfect demographics for creating great discoveries in science and technology. Young people are the people who historically have been the ones who have made the great discoveries in science and technology. And India's young population presents just an extraordinary opportunity. So, for my part, I would say that India's aspirations should be very, very big. I fully agree with Varun that within 20 years, perhaps within 10 years, it should aspire to be one of the top 3 nations in science and technology, however you may choose to measure it. And by the end of the century, perhaps within 50 years, it should be aspiring, so it'll be a long shot, but it should be aspiring to be the #1 country globally in science and technology.
Thanks, Thomas, for setting the goal so high for India, and also commenting on some of the things which makes, why we can think we can go so high, right? Like what you mentioned about the democratic society and this huge demographic base. Just for the younger audience here, right? Thomas was talking about India having a history of advances in mathematical sciences, right? And this goes back to, long time back, right? Thousands of years. So for the kids here, some of you might know about Pythagoras theorem and solving of quadratic equations. And if you see, much before these things were known in the West, they've been known in India and discovered in India and so on and so forth. And even the value of pi has been known for a very, very long time in India. And more recently, if there's one book you guys can go and read about a more recent Indian mathematician is Ramanujan, right? Srinivas Ramanujan. And there's this excellent book called The Man Who Knew Infinity, right? The Man Who Knew Infinity, written by Robert Kenigal, right? Which I would request all of you to go and read and see what kind of geniuses India has produced in mathematical sciences. So going from there, Deepanwita, you have been working closely with translation of SNT now for 20 years, as we were just discussing, right? And you've seen a lot happen already in SNT. So what do you think should be India's ambition with the base we already have in SNT, and where should we focus our energies?
Thank you, Varun. Thank you for inviting me to this panel. So since I see a lot of students here, and if you're talking of 10 years hence, you'll be leading most of the areas. And the question we should ask is, what do you want to be? If the answer is diverse, the opportunities are equitable, and we are willing as a country to give you the opportunity, I think we will be there. So what is very important is to create a culture, the culture of inquiry, the culture of science, the culture of diversity, and the culture, since we are talking of innovation, also the culture of acceptance and risk-taking. And the question is, how do you create that culture in schools, in colleges, in universities, in our workplaces, is to see how do we set examples. Because the best way to do it is by setting examples. And Thomas talked about some examples from early days, and so did Varun. And we need to talk of examples that you can relate to, so that you know that things have happened in your city, in your state, in your country, and you can take it forward. And how do we actually showcase what is happening, what is being done by all of you? I would give two, because there are so many students, just give me, allow me time to give example of something from the city. So, have all of you heard of Bharat Biotech and the Covaxin that came out of Bharat Biotech? Many of you would have, and if you can raise your hands, and I can see some people saying yes. And this is a vaccine that was developed in your city. And we have to really say, how did we, if we have not done vaccine development globally in a period, the short period, how did India do it in this 12 months or 15 months that it took us? It actually involved the government, the research laboratories, and the private sector, which is Bharat Biotech belongs to the private sector, to do the translation. I think when Varun asks me about translation, this is what the path is. You help the research that comes out and the development that comes out from academic labs and national labs to be taken by the industry to develop a product that is useful. And many times you need the government, both as the regulator and the funder, to do such translation. So I think if you're talking of translation, it is all these players coming together to make innovations happen. So I think we would talk a little more before we come to what our ambition is. We can talk about it later. But a question that I have before I pass on the mic to Varun is, while you need to think of things you can do for your city, for your country, today or tomorrow, some of you would also like to do things which are much more esoteric, much more maybe long term. You have to define what long term is, and may not be, you would not understand what the use of it today or tomorrow, like work in basic sciences, in mathematics, physics, and so on and so forth. I think we need to encourage all of that. If we do not encourage science, we won't have great scientists. If we do not encourage technology, we will not be able to solve the problems that we would be facing in the midterm. So I would think we need to do both. Thank you, Varun.
Thank you, Deepanwita. And I think Covaxin is a beautiful example, right? It's a vaccine which India made in record time, and probably some of you in the audience have also got a shot of Covaxin, right? And Deepanwita, later I would like to ask you this question that, okay, we did this vaccine, which was a great scientific achievement. Where would you see it go, right? Like, what should India be inventing 5 to 10 years down the line to say we have arrived? And what can we, if we can give an idea to the students out here as to what they should aspire for building, so some ideas also of the more esoteric things they can do, those examples would be helpful. So let me talk to the other panelists and come back. So on to you, Vijay, who's both been an eminent scientist doing, open-ended research in multiple areas in life sciences, and also been with the government, so has had the advantage of having the view which the government takes and thinks about S&T. So maybe a little bit also about your work, which can help people understand what kind of science is done in this country and what they can do. And then your comments on open-ended science translation and so on.
Thank you very much, Varun. First of all, it's wonderful to be here and really nice to see so many bright young people around. Thank you all for coming. So let me first very briefly answer Varun's question about the kind of science which my group has been doing and what relevance it is to some of the other questions he posed. Now, on the face of it, the kind of science we have done seems very disconnected with real problems. The question we address is, how is a fruit fly made? How from a fertilized egg do you get a fly which comes out and right after it emerges can fly around, smell, taste? So how is the assembly system for constructing this fly? Now this seems unconnected with anything else. But because it is correct and valid that all life on earth had a common origin and is connected to all other life on earth and has a shared chemistry, you can learn about any organism by studying any other organism. So discoveries in the fruit fly on how the fly is made has impacted enormously on how cancer happens, how various developmental disease happens. And this has resulted in many Nobel Prizes to fruit fly, and there's a worm called Sinorhabdatus elegans, people who work on a fish called zebrafish, asking fundamental questions, but the connectivity of all of this with all life has led many of these people to get Nobel Prizes and have great impact. So that's the background. So let me very briefly address some of Varun's points which he made. He made one set of points about basic versus applied research. Should we have mission-oriented research? And should we have, how do we, distinguish between excellence and equity, right? Do we need to distinguish between that? So that is one set. Now there I would say that these questions are more administrative silos, and no matter what you're working on, whether you're working on algebra or applied electronics, you can find very exciting work to do in these categories. About equity and excellence, it's difficult to judge except by hindsight. If you give equal opportunity to people to take whatever route they want, then they will blossom. But two other very important points Varun made, which I think it's important, particularly in a time of national and global environmental, climate change, biodiversity, and sustainable development crisis. And these 2 points he made relate to a connectedness to Indian problems, right? Whether it is garbage dumps or air pollution, or how does one have energy in our context, communication in our context, and so on. That, if everything we do has a direct or indirect connection, but we help to establish that connection with organizations like Deepanwita jumping between one enclosure and the other and communicating, then we will be actually able to address the problems of the commons. And otherwise we will have what is called the tragedy of the commons. So that's very important. Everything needs to be done. And what should be our scale of ambitions? Now there is a fundamental point here which Varun made, that really our ambitions should transcend from individual career ambitions. They are very important. We must also have collective ambitions as schools, colleges, universities, institutions, state government, central government, and so on. And we must have that global ambition to also be part of the world. Otherwise, Thomas's point about us grabbing this century and serving not only India, but the world will fall flat. countries which have had an emerging property of a global ambition in the good sense will be able to do something dramatically in 10 years in the current situation where artificial intelligence, machine learning, mathematics, statistics dominate. These are areas where young people can excel very rapidly. Thank you.
Thank you, Vijay, for those very interesting comments, and especially the example of how it is relevant, how the work with fruit fly is relevant, for all the things for concerned with human health and human well-being, right? And such examples across fields are kind of numerous, right? Like Boolean algebra, right? And all electronics today works on Boolean algebra. Now, when Boolean was doing Boolean algebra, he didn't know that, and it was quite some time back, right? And electronics had not come, or no one had thought that electronics would come the way it has come now, right? So I think the idea about Vijay also administrative silos, right? And like how there's deep connection between applied and what we call as applied and basic research, and they shouldn't be siloed the way we do, and they push each other is a great one. So with that, to you, Sriram, who's works in this super hot area called artificial intelligence, which we all are excited about, and I'm sure a lot of kids also use it without knowing that you're using the fruits of AI. And and you have an industry perspective, having spent time in IBM. So little bit background maybe on AI as well, and how the role of applied basic research and so on has played in AI, and some of your thoughts on how and what India should aspire. And as Vijay was saying, that in some sense we have to take everyone together, right, for the scale of ambition we have. So how do you think about it?
Thank you. Good morning, everybody, and pleasure to be here on the panel. I must say that yesterday I got the best set of questions on AI I've ever gotten. I was interacting with 8 to 13-year-old kids, and it's amazing that all of the questions had no more than 5 to 6 words, but they were often the most profound questions that I have ever received. So I thoroughly enjoyed that interaction. So let me maybe start with a few specific comments on what, Varun, you talked about, and then I'll come back to AI. So you made this question around, should we go after Nobel Prizes and Fields Medal, or should we try and do broadly, right? So massification and I think the answer is we got to do both. And I'll sort of give maybe an analogy with cricket. So, so you needed a Sachin Tendulkar or a Virat Kohli to inspire. And you need those icons to inspire and enable people to take on those careers and see this ambition. So I do think we need science icons. We need the Rex Ramanujam with whom we are all writing books, and because that inspires people. At the same time, we knew that, when many of us were growing up, the chances of becoming a Sachin was very rare. And so you were often asked, okay, there is no way you're going to be successful, so take some other discipline. So I also think that you needed systems. Today, it's possible to have a successful career as a sportsman in India without having to become Sachin Tendulkar, and that incentivizes more people. So I think in science too, we need to have the balance between inspirational icons and medal winners, as well as a successful career that many people can aspire to, because we have a lot of problems and we need all the talent. So I would say it's a little bit of both we got to aspire for. The other comment I wanted to make is around this importance of public-private partnership, which I see working so amazingly. And the example that I want to give, coming from IBM and living in New York, and what's happening now with semiconductor. I think in the last 3 years, semiconductors became, nobody were talking about it, to front page news. It's like national security and cyber security. Your semiconductor reliance is now a national problem. And what I see happening is that there was such a confluence. I see now, IBM has a nanotechnology semiconductor research center in Albany. It's a true confluence of private sector, public funded research, global cooperation, and I don't think that kind of, and it brings so many fundamental scientific disciplines together. There is electronics, there is electrical engineering, there is process, there is manufacturing, there is material science. So I do believe that, and I think in the starting comment, I think you or Varun or Ashish made a comment about the small fraction of industry partnership. I think that is something really, really critical. But I think if we can get these ingredients right, I wholeheartedly agree with where Thomas was going. I think this decade and more is for India's taking. And I really think we have a huge opportunity to really become number 3, number 2, or number 1 in science and technology in the course of time. Now on AI, I want to use AI to address the importance of both solving foundational problems, but also the local India context. So in AI, you know that the fuel for AI is data. So if you are looking to build speech systems, natural language processing systems, biometric systems, solve environmental problems, you can't afford to solve it in the context of the Western world. If I'm looking to build speech systems that work in India, I have to have an India context. So I believe that particularly where data and information becomes so critical, whether you're doing biology or material science or computation science, AI is becoming a tool that I think it's critical that we combine advancing the field of AI, for example, but advancing it in a local context. It has the advantage that now you will be solving unique problems, make a name to the world. You will also be building things that are valuable for local industry. So as opposed to innovating and building something that only an international company can leverage, you will serve Indian companies that cater to the Indian market, and what goes back to my previous point of industry-private partnerships. So I think that if we can get those things right, the world is our oyster. One last comment, and I want to give a different example, very much inspired by what Dr. Vijay Raghavan was saying, around sometimes you don't know when something is going to be useful. So some of you might know about the emerging area of quantum computing and the fact that with quantum computers we might have security broken. So there is an area of security called quantum safe. How do I make things secure so that even a quantum computer cannot break it? And it turns out that the way you build those systems is to exploit this esoteric field of mathematics called cyclotomic polynomials. So very much like, did Boolean think of electronics when we entered Boolean algebra? The mathematicians who were doing cyclotomic polynomials weren't thinking about quantum safe cryptography. But it's going to become the centerpiece of how we make systems secure. So again, we have students of various age ranges here, and I do want to encourage people to realize that sometimes if you have a passion, you see a problem, you make a difference, it may take 10, 15 years for that to really see the fruit, but sometimes the hardest things take time. But I think if we can draw inspiration, we have plenty of inspiration right here in India of things that our scientists and leaders have invented, that I hope to see a lot more of that coming out of many of the folks in the audience today.
Thanks, Sriram. And I think the cricket example was very cool. So you're doing not only AI is cool, but cricket is also cool. But I think because we all are a little older, he said Sachin Tendulkar, not Dhoni or Virat Kohli, right? But on that note, I think all of you should go back and think and ask this question that who's the Sachin Tendulkar and Virat Kohli of science and tech, right? And by the way, a lot of them are here over these 2 days, very eminent scientists who are, Sachin Tendulkar, Virat Kohli's of science. So no, I'm with you, Sriram, that, that big aspiration can be met there and we can get those inspirational figures. While as we have created an ecosystem, even not only in cricket, but even with the OTT platforms, we have an ecosystem now where you can be a successful actor without being on the big screen. So probably those metaphors could help when we are thinking about science as well. You have a comment, Vijay? Go ahead.
I just want to interject that both Satya Nadella and Abbas Ali Beg and Jaisima are from the school.
And I think the second point, which you made is very important about the ecosystem. And I think when India thinks about its science and technology ambition, the role of industry should be very, very big and important, right? And we have seen that happen in the US in a big way. So I think that's a good point which we are not covered. And the third about context, which is that we need to solve and think about science and tech in the context which we have. So let me get a few more brief comments from the panelists and then open up for Q&A. So Thomas, you talked about giving us hope and that ambition that this is the century for India to take and so on. What do you think? And when we were having this discussion yesterday, you were saying that maybe India has a different path, right? Rather than thinking, one thing which we probably do wrong is that we see other geographies and other countries who've been successful and try to go and mimic them in how we do in our S&T. Any thoughts on how India could do it differently or how India S&T might look very different from global S&T and as we embark on that ambition?
What a cracking question, Varun. So, there are some things I think that India has to do the same. So currently, India is very weak in its higher education research activity. India actually spends half as much on university research as Australia does. That's my country, tiny little place, 25 million people. So, and it spends, probably, I think, 10 times less than China and maybe 20 times less than the US. So one can point to specific areas and say, there are certain things you need to have in your system, irrespective of who you are. If you aspire to do well, you need those things. And one thing you do need is a very vibrant university research system. But that said, there may be different ways of getting to the same ends. One thing that China has done is manage a whole lot of policies in a very directed way, in a very centralized way. It seems to me, just walking down the street, that India has a genius for self-organization. That may mean that, that Indian entrepreneurs will actually be able to flourish much more rapidly, given the stage India is in its development cycle, much more rapidly than Chinese entrepreneurs could. It probably means that 3/4 of the people in this room should be, if you aspire to a career in research, should be aspiring to a career in commercial research. But if you have a flair for self-organisation, it may mean too that your funding policies and the way you organise your research system can be perhaps less political, more orchestrated using just simple competitive mechanisms that enable funding to flow based on track record and so on to people who will deliver, rather than the model that exists in many other places where it's who you know that really matters. So that'd be one idea.
No, Thomas, that's very helpful, and both the point around university research and build that ecosystem a lot more than we have. And if I may, you're pointing towards more open-ended research probably than we are doing today, because that's more of what happens in the university ecosystem. And the observation about self-organization was pretty cool. I know you have been walking around the city and observing how it works, and it definitely have its benefits. But a lot of people who come from the West think that there's this chaotic country where everyone decides what they want to do. But I think we have used it to our advantage, and we should think more of how we can use it to our advantage in S&T. So with that, Deepanwita, a little more thoughts on, a co-vaccine example, another example on where we should go, right? What should be the ambition be? Is it that we should be making more world-changing vaccinations and some example of that? Or what should be India's contribution to, let's say, the life science ecosystem of the world?
Thank you, Varun. First of all, I must say what Thomas mentioned about our spending less amount of money. 0.7% of GDP on R&D is really, really small. I don't know how to even talk about it, because if we are not doing 1.5 to 2% of GDP, and our GDP quantum is much lower than that of the US or other, the Chinese economy and other economies. So we really need to spend more on research and development in general, in all areas of research and development. Maybe today 67%, around 67 to 70% comes from the government and the rest from the private industry. It could be, to begin with, maybe half and half, or going forward, it's reversed, like 2/3 from private sector and 1/3 from government. That would be ideal. But I think overall we need to work together to see that the R&D spend is increased. Now the question of what we do in life sciences, the problems in life science, I'm not only talking of the biopharma industry, when I'm talking of life sciences, we should talk of agriculture, nutrition, food systems and all together. And I think there is a lot that India can contribute. Definitely the vaccine program, because we are a country that provides, I think Dr. Vijay Raghavan would be able to say maybe 60% of the global vaccine comes from India. But we are only into immunization and those kind of vaccines, not in the high value vaccines. I think we need to look at that part if you're talking of vaccination. But I think generally on public health, we need to solve our TB problem, tuberculosis problem, and just not tuberculosis, there are so many other public health threats that we need to address. So that part, if we do it, it's actually can be used for a lot of other countries and continents, Latin America, South America, for Africa and so on and so forth. So I think apart from that, we need to focus on agriculture and food systems, because these are not unrelated, because if there is a lot of agriculture, ag tech companies that we say, both from Hyderabad and around India, that's coming up, doing well, but exactly solving the problems, the local problems, and providing food security to other countries, if that can be looked at, it will be fantastic. All this can be, of course, done if we not work as individuals, as Dr. Vijay Raghavan mentioned, if there is a will to work together. So a question that I have for all the children, we are talking of the cleaning of the Ganga. You've seen the Musi River. It's so dirty. Is there a program with all the school children that can come together to clean the Musi or clean Hussain Sagar? So I think we need from the student community to be able to define problems of your city. It is not for the administration to say this has to be done. I think there is a big force here, the college and the school children, they should be able to see, we need our city clean, we need our rivers clean. Can we have that kind? And then we need technologies for the universities to provide us to clean our river. I think that voice has to come to demand the right technologies for solving problems locally. I think that part would be so it's again a culture of science being used for solving your local problems. I think that would be extremely important, and if I get a chance later, I have to quote Maya Angelou, my favorite poet, for one of the things that we could look forward to. Thank you.
No, thanks. And I think, Deepanwita, two important points, right? One, I think India can contribute a lot to public health, right? It's almost like a responsibility with all these developing countries, right? Solutions coming out of India can be way more well-tailored, right? And some of even the medical instrumentation which comes out of the West is so expensive that it is hardly accessible. And India has an opportunity with its strength in frugal engineering and so on to do some of that at scale. And the second one around, problems, and we've not talked so much about the stakeholder which the society is to bringing these problems to us. Mr. Abe Bang is sitting in the audience, and we had this long chat yesterday about, how do we hear the public and how do scientists hear the public and what their problems are and make sure that they are working towards them, which is participatory science, which we need a lot more of. With this, Vijay and Sriram, a few more comments on what you have heard, right? And India's science ambition as you see it unfold, and then we'll open it up for questions.
Thank you very much. Very briefly, those of you who attended yesterday's panel where Dr. Abhay Bang was there, for example, that panel addressed a critical issue, and this is the following. We are pretty good at stating what the problems are which we need to solve. We know what should be done, but we are in trouble about how it should be done because we tend to have a one-size-fits-all solution for the entire country, and the exemplary context, for example, what Dr. Abhay Bang is doing in Gadchiroli, have not been scaled in multiple locations. So how do we deal with size and scale is a challenge. Now, Deepanwita mentioned the Hussain Sagar. The challenge in the commons and addressing that is we don't, as scientists, appreciate the opportunity which the Hussain Sagar gives from basic to applied science of every kind. I mean, biology, material science, chemistry, fluid mechanics, satellites, all of that come into addressing this problem. Why can't we get together and address that? The reason is academic institutions work on a decadic time scale, 5, 10, 20 years and so on. Industry wants returns every quarter. Politicians want a statement every weekend, right? And therefore, these are in 3 different kinds of hard drives, and we need structures which can flit between them and address the commons and have them at their own time scale addressing these issues. That's feasible. There's big return in industry on investment in the Hussain Sagar, and that could be an example where citizens of Hyderabad take up, partner with industry, partner with local government, and solve this in a manner where the structures which flit from these silos are put in place. Thank you.
And maybe building on that, the time scale point, I think industrial R&D has a big role to play in being the bridge. So if I look back at the organization that I come from, on the one hand, I have a stakeholder, which is the business, which really is looking at quarterly returns, markets, money. We also draw from foundational science that we might do that academia does, which has a longer time scale. And our job is, in fact, as an industrial R&D lab, to be the bridge between something happening at 5-year scale and something that wants regular returns and picking the right problems and solutions. And I think one thing that I see not happening enough and missing in India is really Indian corporations continuing to have big, sizable industrial R&D. The lot of the R&D labs are still multinational corporations having R&D labs. And I think that opportunity has many positives. One, it obviously is a way to scale the amount of industrial R&D that happens. Industrial R&D does have this time scale bridging role. And finally, I think you will be solving problems in a local context, both societal problems as well as local market problems. So I think that is definitely a missing piece. And we need to think of, does that require policy intervention? Does that require, taxation pivots? How do you incentivize more industrial R&D to happen, along with setting up structures for these big public-private partnerships? Some of the hardest problems, I think we all agree, are never going to be solved by one institution or one corporation. And I think I agree with the benefit of self-organization, but sometimes for some big problems, you got to put structure together within which, communities and organizations can come together. And I think those are things we should.
Sure. No, I think those are, very important points in the same vein. And it is about these different stakeholders, the industry, the government, the institutions, and so on. And how do they come together to solve problems in context, right? That's the kind of message I'm getting. Let me open up for questions. We have time for a few questions. And if I may, we can get 2-3 questions together, and then, panelists can answer it. That will give us an opportunity to have more questions. Yeah, so one here and then one back there. Yeah,
so I have 2 points to make regarding translational research and fundamental research. The first one is my personal opinion, and the second one is a question. So I'll start by mentioning that I have spent an equal amount of time in fundamental research and translational research. So I did my PhD, so I was associated with academics for 5.5 years, and now I have been with TCS's R&D division for 5.5 years. So what I personally believe is there should be, in India, there should be a slightly more emphasis on translational research, because let's say, take the case of diagnostic biomarkers. So some of them might not be equally accurate across demographies. Or let's say certain technologies might not be scalable across India. Or even some business models may not work in a country like India. So in such kind of scenario, I think we need to have our solutions for our problems rather than be more engaged in problems for countries outside of India. So this is my personal opinion. The second one is something that I have observed about fundamental research in India from my limited sampling. So although I did my PhD in India at IIIT Hyderabad, I've also spent a few months in Germany for a small part of my PhD. So the major difference that I noticed was people, this is not with regard to my lab in India or lab in Germany, but in general what I noticed was people there was they were more willing to take risks. And here there was slight inertia, to play safe while defining problems and approaching problems. So how do you think we can, have a culture that will help us overcome this inertia in India? This is once again from my limited sampling set. May not be applicable to all institutions across India or Germany, but yeah, this is my observation.
No, that's a good observation. I think it fits well with the larger ecosystem, so we'll come to that. There was a question there at the back, please.
Hello. Hello. Like, I don't know how many of the people know very well regarding the GDP and all the R&D things, but I think we should start changes from the roots, like starting from the teachers, because one single teacher can influence hundreds and millions of students. So, what to say? Like, there is a proverb in Chinese, like instead of making them to build a ship, hello? Yeah. So instead of teaching them to build a ship, they should know the importance of the sea first. Then only they will start the feeling to cross the sea. So the students must know the importance of why we should improve the science and why we should participate in science. Because like whether the student wants to become a lawyer or else a businessman, but they totally depend their life on science and technology. So they must now have a basic awareness of all those. All those things come from the basic roots, from the teachers. So I think we should start from the roots.
Sure. Do we have any other questions? We can take one more and then have... Yep.
Yeah, look, I just thought it'd be nice to make a comment on the previous person's remarks. I actually think there's a big question for India around medical and life sciences research. If you look at the research portfolio of the United States, just based on scientific publications, 50% of its output is in life sciences. Much of that, the lion's share of that, relates to medical research or more fundamental biomedical research. India's pattern is very different. India has a broad base of outputs across research fields, as one would expect for a country of this size. But the distribution between disciplines, it actually looks very similar to China's. Particular strengths in computer science, some strengths in engineering, chemistry, materials science. There's some great capability in life sciences, but the scale is significantly reduced as a share of the total portfolio relative to what one sees in the United States, or in fact many other developed countries. Now, that's not to say that's the wrong model. It may well be exactly the right model, because in the first instance, it does make sense to have a public sector research system and a university research system, the strengths of which are aligned with what's happening in industry. So And that's more or less what seems to be emerging. The reason I think this is a really interesting issue for India is that in a way that was not true of China, India does have a pharmaceutical sector. India does have an emerging biotech sector. And so it just looks to me as if this is an opportunity that hasn't yet quite been grasped in India. And that's an issue that I would be raising with policymakers. Is it time for India to start to make a move in some of those other fields in the life sciences? China is now starting to do that, but it now has the scale to do so. China had the model that it would start with a few disciplines, build them up, and then over time add new disciplines to its portfolio. But it may be, partly for the reasons you've outlined, that now is a good time for India to start to move in the life sciences as well.
Thanks, Thomas. We'll take one more question and then have comments.
Good morning to the panel and the audience. I'm a teacher basically in a school, the host school. What should the teachers, how or what do you, the scientist or the specialist, feel at the school level to increase the science cue or the thought-provoking style we have to follow, or maybe the buzzwords or such kind of experiences does inspire few minds, but by and large when it comes to the academic demands which are penned down by the policies and the educational policies, beyond the classroom, what do you see what we should be doing so that the science can get more fruitful in future? Thank you.
Thank you. So two questions around teaching and one around more risk-taking research from India, which Thomas talked a little about. So maybe, we can try to address these questions and also have concluding words at the same time. So we can start from this side.
Sure. So maybe I'll start with this comment around, risk-taking. I think that observation I heard now, I think in multiple panels over the last couple of days, that somehow, that we don't do enough of. And maybe that is somewhat true. It's maybe left over from the era when we were still trying to come up as a country. I do believe it has changed. It has changed in the venture industry. It has changed out in the market. I think it needs to percolate back into our academic systems and labs also. But I'm just saying that I think that's a cultural shift more than anything else. It's starting to happen. I definitely see that a lot more in when you talk to companies and startups, that the risk-taking capability or the confidence that something will happen has dramatically changed generation to generation, decade to decade. On this issue of what to do in schools, I think, and this I'm speaking as the father of two young daughters, the question that always comes up is, why am I learning this? I think we do not yet do enough to associate the impact or explain to the kids the impact of what they are learning and how it is. Without all that they are learning about science, they wouldn't have the life that they have today, and that this is crucial to solve the hardest problems. I think that link somewhat is still missing. I don't know whether that is a testament to teaching to the test or the curricular pressure, but as a father at least, that's what I hear them tell me all the time. Why am I studying this? Why is this ever useful to me in the past or in the future? And I think we have to change that, because once that link happens, I have seen a perceptible change, and we do see that. So that's something to think about as what can we do to bring more examples and more practicality to what we teach, as opposed to just telling them to remember a bunch of things and respond and do well in the exam. And I think the other question was around, it was a focus on teaching, so I would say that sort of relates to the same conversation.
Thank you. I'll just quickly address the point about teaching. Teachers have an extraordinary and disproportionate impact on kids. And that can happen in both directions. Today's kids come from family structures which often are caught up, whether you're lower middle class, poor or rich, in dealing with the real world with an intensity which somehow reduces attention to learning and inquiry in the family structure. Therefore, that role also falls on the teacher to some extent. And if the teacher could identify, not just in science, but in sports and humanities everywhere, talent and interest, and gently direct the students so that outside of school, with their parents, with the society, they can explore these spaces both in real terms and in virtual connectedness, then the students can blossom, they'll get the kind of meaning which Sriram talked about. Thank you.
Thanks. Again, talking about what teachers, the responsibility of teachers, of course, is a lot. You know, I think history of science is something very important. At times, school teachers do not talk about the history of science, why something has come out, right from whether it's Galileo, whether it's Newton. So because science is so interesting and it has to be, you don't need to make it interesting, but just talk about how science has emerged and the entire path. I think history of science has to be part of the curriculum, and if it is not, I think teachers have to take time out to talk about it. And experiments, doing the right kind of experiments, and let students experiment, even if they can't do it well, just give them whatever tools and they will find out what to do with it. And I think that would make science interesting. Everybody is not cut out for science, and that's perfectly fine. If somebody does not want to really focus on science, they may be inspired in some other way. And I can give you an example of Carl Sagan's. So if you have heard of Voyager 1, the pictures that Voyager 1 took from outer space of the Earth, and it was called the pale blue dot. And Carl Sagan was giving a talk at, I think, Cornell in 1994, and a humanist and a poet, Maya Angelou, she was there in the meeting, and she wrote a poem that in 1995 was awarded and as a United Nations poem. I think one can be inspired very differently by different things. So there is no boundary that when somebody talks of science, a person from humanities or a person from another discipline will not take the cue and understand. So I just wanted to read the last lines of this poem. When we come to it, the name of the poem is The Brave and Startling Truth. When we come to it, we must confess that we are the possible. We are the miraculous, the true wonder of the world. It's not the pyramid, it's not anything else. We are the wonder of the world. That is when and only when we come to it. So we have to come to the point to understand what we want to do, and then we are absolutely wonderful, and we are the possible. I think the children are the possible. Thanks.
You have any more comments?
I'm loath to add something after that beautiful poem. Perhaps we should have stopped at that point. But could I just say that I think that's the most important issue that needs to be addressed. And interestingly, the question about how to educate ties in with the question about risk-taking. In the English-speaking world, we have arrived at the mistaken view that there's a trade-off between learning things in a disciplined way and learning to be creative and to take risks. And as a consequence, in the United States, in Australia, in Britain, we have experienced declining educational standards, particularly in mathematics, to a lesser degree, but also significantly in science. And that hasn't mattered for us because we've been able to import talent from countries like yours. There is the potential for a trade-off, but I think it's exaggerated. What really matters is that you do inculcate in people a culture of risk-taking and expressing dissent, but it's most important that people have a discipline and understand the basics of the sciences, and particularly of mathematics in the modern age, because every area of science is now underpinned heavily by mathematics. Of course, only a tiny minority of the population will end up working actively as researchers, but if just a tiny fraction of Indian students excel in mathematics and science, you'll have countries' worth of researchers ready to work for you. So those are my thoughts.
Thank you, Thomas, and thanks all the other panelists. I'll just quickly summarize in one line, though it cannot be, that I think this is the decade and century for India to take in SNT. We need to align all our energies and focus to, it's a big opportunity, right? And India can really excel in SNT. So we need to channelize energy towards that. Basic, applied, mission-driven, local problems, global problems, we need to see it as a continuum rather than silos. And if we work on all of these in unison, an ecosystem has to be built which kind of works on all of these in the Indian context. Then we can reach the mission which we want to. And finally, the questions on teaching and so on, right? I think students are our strength. We need to raise their curiosity, right? If we can raise their curiosity towards science, right? And you don't know, for me personally, there was this teacher who came in a arrangement period when your teacher doesn't come and told me about this book, The Man Who Knew Infinity, right? And I read it and it just changed my perspective of how science can happen. So teachers are like immensely powerful, right? And the power of teachers and role models cannot be understated. So with this, we should build this new generation so that, India can be there where we want it to be in science and technology. With that, thanks all on the dais, and thank you, audience. Thank you.